Alright everybody, it's Thursday night, and I don't want to waste any of your time, so let's get right into the lesson, shall we? Bam! Today we are going to learn about explicit exponential equations. In yesterday's lesson, we took recursive geometric sequences, because it was a geometric recursive sequence, we were multiplying to get from number to number to number, to get us from the 0 term to the first term, second term, third term, fourth term, 50th term, and so on. But what if you want to find that 50th term, but you don't want to have to just keep going enter, 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 enter with your calculator 50 times? You just want to plug 50 into the equation and get an answer. That would not be a recursive formula, that would be an explicit formula. That's a typo, I should have written explicit. So let's write an explicit formula for this situation. First, I want to build a table of values here just to kind of explain it. Because we have our x and we have our y. And it's telling us right now that when you plug 0 into this formula, 3 is what needs to pop out. But then once you multiply it, multiply by 5 once, that first term would then be 15. If you then plugged 2 into your explicit equation, 15 times 5 is 75. So when you plug in 2, you want to get 75. When you plug in 3, you multiply by another 5, and now Elliot's going to have to cheat. He doesn't. Oh wait, he does. 75 times 4 is 300. So times 5 must be 375. I'm going to use my explicit formula that I'm about to devise to check that 3 to see if it's right. Alright, now, when I look at 3, let's break this down into primes. 3 is essentially just 3. 15, that's 3 times 5. 75, that's 3 times 5 times 5. In theory, if I multiplied it right, 375 would be another one, times 5 times 5 times 5. You seeing a pattern here? And this, when it's 1, I multiplied 5 just once. When it's 2, I multiplied by 5 twice. 3, I multiplied by 3. Or maybe we could write it like this. This is just 3. This is 3 times 5 to the 1. This is 3 times 5 to the 2. This is 3 times 5 to the 3. Well, if I follow that pattern, what would this one be? Well, this one would be 3 times 5 to the 0, which kind of makes sense because there are no 5s up there. And 5 to the 0, as everybody knows, is equal to 1. Anyway, if we continue on this pattern and we wanted to figure out the xth one, the x, if I plugged x into the formula, what would it look like? Well, if you use this as a guide, the 3 is always the same, the 5 is always the same, and the only thing that's changing is that exponent. And it appears that if this is a 3, we can have the exponent be 3. Or in this case, if the number is x, it would be 3 times 5 to the x. So in this particular case, our explicit form, I have to go back up here. This wasn't a formula, this was an equation. Just like it says here, explicit equation. And so it's y equals 3 times 5 to the x. And because it has an exponent of x, that is what makes this an exponential equation. Excellent. Well, that's part 1, just the theory on exponential equations. Let's come up with a formal formula. And if you are a minimal note taker, at the very least, please write this down. Do I want to use a UN? No. I'm gonna use an f of x. F of x is equal to, this 3 represents the 0th term. So u0 times this 5, that's the multiplier, because we're multiplying it by 5. So what would I put for that? I'd put our common ratio Yeah, right now I'm just going to write the word common ratio. And that common ratio is being raised to the xth term. And then this formula will work for all of our exponential equations today. They will get more complicated in the future, but for today, that's enough. Okay, so part 2 is going to be examples. Part 2 of today's lesson is examples. And like I said in yesterday's lesson, try to get in the habit of actually working out the examples. You can work out the examples before me, with me as I'm solving them, or you can also do it after. So what I'd like to do is I'd like to actually put today's examples up on the screen to give you an opportunity to write them down if you'd like. Make it even bigger. Okay. So here we go. So if you're watching this right now and you're going to do these problems ahead of me, pause this. You're going to find the missing term, blank, blank, 48, 24, 12, blank, blank. We have a story problem about Marshawn. It's Skittles. It's Seahawks problem. Anyway, you're going to see a common theme. Part A, find the first 4 terms of the sequence. Part B, write a recursive formula. Part C, write an explicit formula for the sequence. I should say explicit equation for the sequence. And then they're going to ask you, a secondary question. So that's number 2 and number 3. So just pause this video for a minute and so that you can get this problem. And then I actually have a 4th example. It looks like that. So pause, get these problems written down, or at least the key information for it. And then you can solve these problems as I solve them, before I solve them, after I solve them. But make sure you can do these 4 examples before going to bed tonight. That'll help you out mightily tomorrow. So my first example, you want to know what, everybody? I'm going to print out this worksheet so that I can use the paper version of it. You're going to have to give me 1 second here. Page 1, print. All right, sorry about that. I'll be right back, everybody. Oh, it printed up the wrong page. I have to do it again. Sorry. Print page 2. All right, sorry. All right, Elliot's back. Let's do some examples. First example. If they give me a list of numbers here, how would I, and they tell me that it's a geometric sequence, how would I find the numbers before and after it? Well, you need to find the pattern. Knowing that it's geometric, when we did this earlier, we always took this number divided by this number, and 24 divided by 48. Well, that's equal to 1/2. So my constant multiplier, or my constant ratio, is 1/2. So 48, 24, 12. 12 times 1/2 is 6. 6 times 1/2 is 3. And then in the other direction. And if you're going to go in the other direction, you could think of it 2 ways. Instead of multiplying, you could think of it as dividing. So 48 divided by 1/2. Or you could think about it this way, is you're going to multiply, but multiply by the reciprocal. So instead, if you multiply by 2 instead of multiplying by 1/2, you'd get 96. And then if you multiplied 96 by 2 over 1, again, the reciprocal of 1/2, you'd get 192. So you could either divide by that very number, so divide by the 1/2, or you could multiply by the reciprocal too. A couple different ways of thinking about it. All right, that was number one. Let me get into number two, my first story problem. All right, so recursive formula for part A. Starting off with 3 Skittles. Cheer him up by doubling his Skittles each hour. So 1 hour later, he will have 6, the doubler. We're multiplying by 2. An hour after that, you multiply by 2 again, you'd get 12. You multiply that by 2, you'd get 24. And that would be the first 4 terms of the sequence. A recursive formula. Right now, that's U0 representing now, we have 3. But each hour, you're doubling, so you're multiplying by 2 with n greater than or equal to 1. And then we can turn this into an explicit formula in part C. We can just use that formula that I gave you earlier. So we could use f of x equals u0, which is 3, times the common ratio, which in this case is 2, so times 2 to the x. But this is a story problem, so you totally have to identify your variable. X is, this is each hour. We're giving him more Skittles, so x is the number of hours. These are story problems. Always identify your variables in story problems, students. Thank you. All right, let's see. Now in part D, we're going to use our explicit formula to figure out, figure out what's going on. So how many Skittles will Marshawn have in 24 hours? So we're doing f of 24 equals 3 times 2 to the 24th power. And of course, my calculator will do that for me. If you want to do a big power, there's this button right here. It's called the caret button. I don't know why they call it the caret button, but it is called the caret button. So 2 to the 24 will give you some kind of gigantic number. Then that times 3 to hit up that to finish off with the equation. And I ended up getting 50331648. And then you want to put some commas in there. So comma there, comma there. Whoa! 50,331,648 Skittles. That Marshawn, I bet he's a happy guy now. Okay, so that's number 2. Number 3, then in all honesty, story problems 3 and 4 work very similar to what 2 did. They're just slightly different words. So if you're feeling pretty confident at this point, you might not need the rest of the examples. But if you're still a little bit lost, let's do example 3 together. This one's a decay. Okay, so bike currently costs $800, or it's worth $800. Now, if it's going to decrease in value 9%, that means it's still worth 1 minus that 9%. So if you went 1 minus 0.09, you get 91 or 0.91. So if it's decreasing 9% in value, that means it's worth 91% of its current value. So that's our current multiplier. We're going to multiply by 0.91. And I'm going to use my calculator for that. So 800 times 0.91 gives me exactly $728. And then times 0.91 again. And now my calculator says answer, so it's going to flow a little bit easier. 662.48. Hit enter again. And now it's 602 point. How many decimals should we go? Well, we're talking real life problem and we're talking money. And in America, we go 2 decimal spots. So I'm just going to go 2 decimal spots. 602.80. Well, let's see. If this is your bike value, you want to project a strong bike value. So I would probably round this one up to 86 cents. All right, those are the first four terms. Part B, the recursive formula. Well, that first number is 800. And then after that, you take the previous term and you multiply that by our constant multiplier, which is 0.91, with n greater than or equal to 1. Part C. Like I said, use this formula here. U0 times the common ratio to the x. So f of x is equal to my U0, my first number, then my constant multiplier to the x. But what's x? X is, what's going on? Each year it's decreasing 9%. So x is the number of years. Then, how much will the bike cost in 7 years? Well, that's part D, where we do f of 7. So 800 times 0.91 to the 7, and that is equal to, I can just 800 times parentheses 0.91 to the 7th power. Close that, and I got an answer of $413.40. I'm going to round that up to 41 cents. All right, that's number 3, a bicycle value problem. I love bicycles. They're awesome. Okay, last problem. This problem is about a diamond. Maybe you have a special someone in your life and you'd like to give them a diamond. Nice. And like I said already, if you're feeling confident about this stuff, maybe you don't need to see all of these problems. And in this particular case, I'm going to do part B first, because wouldn't it be easier to come up with the recursive formula and then find the first 4 terms? Just saying. Well, in this case, right now, this is worth $840. This diamond is worth $840. Now, to get to this next one, its value increases by 1/3. Well, if its value is currently 100%, adding a third, oh, that's going to be tricky thinking of it as percent. So maybe you should think of it as just a number. If the complete value is 1 and you added a third to that, 1 plus 1/3, or 3/3 plus 1/3, that's equal to 4/3. So if it's increasing by 1/3 its value, that means that you could be multiplying it by 4/3 with n greater than or equal to 1. Now that I have that, I can back up and do part A. I have 840 and then times 4/3. So 840. Oh, this is what I'm going to do. Just get it going. I'm going to hit 840 and hit enter so that my answer is already 840. Then I'm going to go times 4 divided by 3. And my next number will be 1120. Then 1493.33. And we're talking money, so I'm not going to keep it exact. I'm going to keep it to 2 decimal spots. Now notice that when I do my next multiplier, I don't use the 0.33. I continue to use the entire decimal to keep that answer as accurate as possible. And I got 1991.11. And you can go 2 decimal spots because we're talking money here, American money. That was part A, and I've already done part B. Part C, the explicit. F of x is equal to U0, 840, times the common ratio of 4/3 raised to the x. And then the explicit formula is handy because if I want to see how much that diamond is worth in 23 years... Oh wait, I forgot to label my x. X is the number of years. And I guess we should label our f of x too. X is the diamond worth. So f of 23 equals 840 times 4/3 raised to the 23rd power. And your calculator can do all that in 1 bit. 840 times parentheses, 4 divided by 3, close parentheses for the 4/3, raised to the 23rd power. And my number is 62787, 0.7. I'm going to raise that up to 72 cents. So nice. $627,870.72. I'm really glad I bought that diamond. Okay, so those are the problems, these 4 sample problems. If you have not yet done these 4 examples on your own, now that you've seen these problems worked out, go back and try out these examples and make sure you can do them and get the correct answer. You don't just want to go to bed without writing any of this stuff down. Don't watch me like I'm a television show. Be an active participant. Make sure you're trying these examples. And that's pretty much it. That's all I have for you. If you can do these 4 examples, I think you're in a really good spot, and tomorrow's practice is going to go very smoothly for you. Whereas if you can't do these examples, it's going to be tough. So go back, make sure you can do these examples on your own before getting to class tomorrow. Have yourself a great Thursday night, and I hope the football team won their game. Go Skyline. Bye, everybody.